Hello, everyone. Welcome to today's webinar on overlays and widening projects inside of RoadEng. I'm your resident webinar host, Erin, and I look forward to sharing a lot of really great content with you today. We are going to be focused on a widening project that actually has a decent amount of work to upgrade it to make sure it meets its road class specifications. So we'll also be tackling a little bit of a realignment as well. To get started, a few pieces of webinar housekeeping. First and foremost, you're all going to be muted throughout the webinar, but if you would like to ask a question, you can do so using the question section of your GoToWebinar panel. Type your question in there at any time. We'll tackle them at the end, and all question askers remain anonymous. Second piece of housekeeping is regards to our pace. So these webinars are really meant to be sort of workflow demonstrations. They're not follow along webinars, but we encourage you, if you are looking to follow along with it in the future, grab the YouTube link once we get it posted, and you can certainly do that there. And then finally, our biggest piece of housekeeping, today's webinar is actually going to be done in our unreleased upcoming version 12. So that one it's still in development, out in beta with quite a bit of the functionality. So we're going to be doing it in 12. Beyond that, let's take a quick look at the workflow for today's presentation and topic. So to start, the very first piece of our workflow is modeling our topo data. So for this, we're going to be using conventional survey data as well as DEM data. And in the very first step, we're going to import and model that total station data. Specifically, we're going to bring in data for the center line and road edges of that existing road that we're looking to do our widening and overlay project on. Our next step in the workflow is going to be bringing in additional data that can represent the rest of our surface. So for this, we've got some, I believe it's DTM or DEM data that we're going to bring in, import, and leverage for that rest of our surface. In our third step, we're going to merge those two topo surfaces together and then save that file. And this is going to serve as our base for our location project, where we're going to go in and actually start to do the overlay and widening work. So the first few steps of importing the topo surface, topo data, both formats, and merging was all done in our terrain module. From there, we're going to switch to the location module, where we're going to use the surveyed center line as our initial alignment, and that we can then reference that terrain surface as well. Now, of course, RoadEng is all based on templates. And a lot of our projects, this is a really important step. So in today's webinar, we're going to be using actually a new version 12 template. If you're interested in it and think it's relevant to one of your projects, please contact us. Although it's a beta template, we're certainly happy to make it available for early access if you need it. So we are going to be working with a gravel overlay and widening template. We're going to configure this template to reference those surveyed road edges and to have better ditching and cut and fill slopes. So a really cool template. We're going to step through that today. And again, if you go to find this one and see if it's available in your version 11, it's not. It's because it's a beta template coming with 12. But again, you can contact us for early access. So now in our workflow, we've got our cross section set up, we've got our center line in, and then really it's about starting to make some of those alignment improvements that I mentioned, as this one is going to have a bit of a realignment to it as well. We'll make a copy of our alignment, then we can run a few different tools that we've got that are going to help us sort of best fit that alignment. And that includes running Polyline to alignment, as well as we're actually going to use the vertical optimizer. And I know it seems a little strange to use it for an overlay and widening project, but we can use the vertical optimizer to help us find that line of best fit for our vertical. And as you're going to see in the example that Matt's going to start running here in a moment, this example actually requires a fair bit of realignment, particularly in the first kilometer or so, as it's really, sort of outside of its road class specifications. So we're going to look at using those tools, figuring out some adjustments to the alignment, and then we're going to show you those couple version 12 features that we were why we're using it, which is we're going to break the alignment, realign a piece of it, and then use the join function in order to connect the pieces back together. So that's the one version 12 function that we're focused on today for inclusion. From here, nice graphic of what we're going to do next, which is the output. So we are going to focus on getting our volumes, earthworks, as well as any other outputs that we might want. And with that, I am going to pass the screen over to Matt. We're going to get into the software. So Matt,
Alrighty.
over
Yeah,
to you.
sounds good. I'll share my screen and we'll roll right along. So, as per usual, I'll start right from scratch and kind of talk my way through the workflow. So we're going to start out in terrain. We are going to click Insert File, and I'm going to bring in my survey data. And for this one, where we're combining conventional survey data with remote sense data, well, we're going to make two surfaces, and then we're going to make a third that combines them. So I'm going to start with my conventional survey data. So here we've just got a CSV. The surveyor went out, shot the center line, shot the road edges, and away we go. So I'm going to bring that in. I'm using an IOP that I have set up. And what that IOP does is we can use our standard survey specs and have the software automatically connect the dots for things like our point codes. So here I've got everything that's shot as a center line is going to be brought in, and those center line shots are going to be connected as break lines. That particular symbology is going to be applied. And then I've got my road edges shot as well, and those are going to be connected for me. Data is projected, we've got that set, and we can see, as promised, 3 lines, one road edge, center line, and the other road edge. Now for this, since I want to take this surveyed road top and plop it into my, the majority of my topo data, which is from LiDAR, I'm going to make it so that this surface area is limited. And for that, I'm going to use these road edges as tin boundary features. And before I do that, I'm going to just connect them to be a single feature. So I've joined those two on that end. We'll go up to this end. I'm going to come around there, and we are going to close it. And then we're going to click tin boundary. We'll hit apply. And just a note, when we first brought that in, we have 3D points and lines. And then here we'll convert it to a surface by clicking terrain modeling, generate, and there's our surface. And it doesn't look like much, but it will get plopped into the bigger surface here momentarily. I'm going to hit save. We're just going to call that TS road. Let's pop open another instance of terrain, and we'll bring in our LiDAR data. And I say LiDAR data, DEM in this case, so kind of using the two data types interchangeably there. So we'll bring that in. We'll hit OK. We'll check that surface. All right. And then we're going to take that surveyed topo and stitch it in here. So for this, we're going to go to terrain modeling, click merge terrains. We're going to navigate to that terrain file that we've just saved. And we'll hit OK here. And it's going to think for a moment. So it's basically clipping out all of the LiDAR data on the road top that overlaps with that surveyed surface that I've created, setting that data in, and well, we'll create some contours here at the same time, just to add a little more context for what we've got going on here. And there we are. So we have our surface built that we're going to design from. And just a quick note, in here we are going to use those road edges when we get into our overlay and widening portion of our design, and that feature is called Hull S. So I'll hit save. I'm going to just save this as topo. And we're going to switch over to location. So in location, we're going to create a new file that references that topo that we've just created. We are going to not use the hull feature as our initial alignment. Instead, we have that surveyed center line. So we could, of course, trace in where we think the road should go, but we have that surveyed feature, so we might as well use that, at least use it as a starting point. We'll click done. And there we are. Now, I'll click zoom to extents here. We'll zoom in a little bit and we'll talk a bit about what we have going on. So this project, we have that existing road, and right now our center line is a carbon copy of it. So each vertice on my alignment here is an actual surveyed point collected by the surveyor. If we wanted to, we could go a little further here, and well, we're going to set this up. It's a gravel road. We want to widen it. We want to overlay it, and so we are going to set a template up to account for that. So we're going to click templates. And here I can see I've got my 3 default cross sections showing up. And as Aaron introduced, I'm going to use a template that's going to be on the E library here in V12. So it's not an 11, not on the current E library here. So instead, I'm going to just merge it in. And by merging a template in, it adds to the list. So this one is sitting right there. We've got 2 items in that TPL file. And here's the template that I'd like to reference. So this overlay template, the big difference in between it and a standard roadway component is that we're going to account for what happens above the existing road a little differently than if it was just a standard greenfield construction project. And for this in particular, well, we've got our center line, we've got gravel being added above that center line. So here I've got my center line attached to subgrade. And here though, if I'd like to, I'm going to say that if I'm adding fill on top of my existing road, I want to track that fill on top of the existing road as something separate. So in the context here is if we've got a small thin fill on top of an existing road, I probably don't want to have the same specs as my standard subgrade, where here I probably want to account for maybe a select subgrade material where it's free of oversized material. So we have that. Now I'm going to, over here, I'm going to click add. So I'm going to set up a new template and I'm going to call this OW for overlay and widening. I'm going to set my crown. And I'm going to take that component here, paste it into that template, and we're going to make a few adjustments. So with this particular project, I want to have or shoot for having a finished running surface width of 4 meters. Now, we could tell it that that existing road width is a set value, but since we have the actual surveyed road edges that we'd like to use for that, instead of using a set value, we're going to use an offset that ties to a feature. So that's going to be a reference feature. So we'll click the little plus here. We're going to add in that reference feature. It's going to come from our topo file. And we're going to scroll down, and it's Hall S that we'd like to use there. So with this, we have that selected. We're going to select that RF1 applies that. And here we can see if we moved our center line a bit, that existing road location stays the same. So we're going to make a couple more tweaks here. I'm going to just flatten out my fill slopes for these surfacing materials a bit. I'm going to apply the same thing on the other side. And here I'll grab a ditch, paste as left, so that ditch doesn't appear unless we're in cut. I'm going to configure that ditch. Again, I'm going to use fairly gentle slopes. I'm going to go with a V ditch here rather than a U ditch. And we'll hit paste as right. And then we'll grab our slopes. Now here, I'm going to say, well, if I'm in cut, I could use auto and apply ground types. Here I'm going to go with just a standard slope of cut slopes 1.5 to 1, fill slopes 2 to 1. So we have a template flushed out. Now this template is called OW. We'll hit OK. We'll hit OK. And nothing changes here yet because that template isn't applied. So if we go in here, we can hit it. Assign by range. And I'm going to apply that new template for the whole road. And if we zoom in, we can see that that little material here, that surface 4, is being tracked as we'd like. And then we've got the subgrade being accounted for elsewhere. Now with this, if we zoom out, well, we can see that it's a decent amount of work. Now our center line is still exactly where the surveyed center line is. But even with that, we've got a decent amount of cut in spots in order to get that out to meet our preferred cross section. Now, if we're looking at this critically as well, I've got some pretty tight vertical curves here. I'm not sure what my horizontal alignment's doing in terms of the radius that we're using on the alignment. But if we wanted to keep this as a pure overlay and widening project and not do any realigning and not really assess the geometry that we have, we could stop here, maybe throw in a few pipes, go to our documentation, and we've got a model. But it would be an awfully short webinar if we did that. So we're going to take it a little further. And we're going to use polyline alignment to figure out what curves we're actually dealing with here, what grades well, I guess grades are known, but what kind of K values we're dealing with on our vertical. And we'll do this as a separate alignment, kind of an option. And then we'll make an informed decision if it makes sense to leave it where it is, or maybe we explore realigning things. So I'm going to just duplicate my alignment. And just so I don't have to look at that other one here, I'm going to just turn some stuff off. So we've got that duplicated alignment. And well, first we're going to apply some proper curves to our horizontal. So here I'm going to go up to corridor, I'm going to click operations, and I'm going to say, well, let's use the polyline to alignment tool. So that's surveyed alignment. We're going to tell it to, well, fit at tightest curve we can fit is a 100-meter curve. We're going to give it a tolerance. We're going to allow it to deviate from those surveyed points up to 75 cents. We'll hit OK. We'll let this thing go. And what it's going to do is it's going to reduce the number of IPs to as few as we can while staying within that tolerance. And we can let this run. We can let it run for quite a while. Well, not that long. It's pretty quick. But here I'm 17 IPs. I'm good. I'll just hit cancel rather than letting it run for the full minute or however long it would take. And there we can see we've got, well, our 100-meter radius curves, 120 there. So we could go along and we could check to see how we're doing, but we know we're within that 75 cents of the surveyed center line to start. Now our vertical is a little different. And for this one, we could go through and we could add in individual IPs and kind of flush this out manually. But I'm going to try and save myself a little bit of time and get kind of a defendable solution where I'm going to use the vertical optimizer to fit some curves to this and figure out what the actual geometry is that we're dealing with in terms of those vertical curves. Now for this, the vertical optimizer, kind of at its core, it's looking to minimize earthworks. And with that, well, here, for example, if we left our cross-section geometry as is, it would look and see that we've got this fairly large cut as we lay back those existing cut slopes. And it would look to use that material to balance my cuts and fills. And that's not really what I want to do here. Instead, I wanted to just kind of look to try and find the alignment that's closest to that existing ground. So I'm going to do something that might not be overly intuitive here, but I'm going to create a new template that is symmetrical and it's narrow enough to stay on top of my existing road. So no cuts and fill slopes extending out from that. And yeah, so here I'm going to, let's use this guy as a starting point. And since it's a temporary solution, I'm not even going to worry about renaming it. I'll just leave it as XX0. So I've got cuts and fill slopes. I'll also just grab a link to add a little bit more geometry to it. So here I'm just going to add a flat spot before that cut and fill slope is applied. And I'm going to set my cuts and fills. I'll go 1.5 to 1 for both. So again, here, if I wanted to follow the existing ground as closely as possible and not favor a solution that's more cut than fill, we'll want this to be symmetrical. So cuts and fills equal. We'll hit OK. We'll hit OK. We're going to apply that. And then I'm going to go over to the vertical optimizer. And again, it's the vertical optimizer is really set up to, well, solve a harder problem, I guess, to sum it up. So I'm going to change a couple of parameters here just to make it better suited to follow that existing ground line. So here I'm going to use a narrower vertical control than I usually would. And I'm going to be quite generous in my max cuts and fills. So here, I don't want to tell it to design my road for me. I want it to match up with what's there. So I don't want to have a solution that is more constrained than the original. Same idea with my vertical curves. I'm going to allow it to have something way tighter than what I'd actually expect or want. And we'll hit add edit here. And then here, we're going to add in a minimum curve length. And that's going to help us avoid some little undulations in our solution. And just a note for that, we want something that's larger than our auto interval spacing. Ideally, at least 2 times. So auto interval spacing for me was set at 10. We'll go to 20. Next, we're going to add in a couple control points. So we want to tie in with the existing road at the start and the end. And, well, we could add in more, but here we don't need it. Last thing that I'm going to adjust for this that's a little different than the new normal application for the vertical optimizer is I'm going to reduce the VIP reduction tolerance in my smart curve settings. So I'm going to only remove really small curves or small undulations, so it is allowed to track that as closely as possible. We'll hit process. It's not instantaneous for what it's figuring out, but it's still pretty quick. We'll pause here for a moment while it thinks, and we should see a reasonable solution fairly quickly. All right. And ta-da! We'll zoom in here and we can see what we're up against. So off the bat, we've got some pretty tight K values. We've got almost a 7 there. We're coming up a little over 10%. And, well, then we've got this nasty vertical curve here where we've got a K of less than 4. We've got that sag close to 6, another K close to 4, K around 5. So it is a pretty tight geometry and kind of outside of the realm of what I'd like this final solution to be. And if we kind of go back to here, well, even if we don't do anything to our alignment, we still have to do a lot of excavation to lay back those cut slopes. So maybe it makes sense to realign this. Now from about here on, we see that we're tracking the ground very close. I've got one tight curve, but I can live with that. The rest is largely up to my desired spec where I want to be able to support 50-kilometer-hour design speeds. So if I wanted to mix and match and have, well, part of this kind of treated as a major realignment or a full rebuild, and part of this treated as, well, just work with what's there, we could do that. So again, adding another layer on to what we're dealing with here. Well, let's split this thing at our current point. So I'm going to break my alignment. And for this first chunk, I'm going to, well, set it up to do my optimization as though it were a new build. And this latter chunk, well, we'll keep this as that overlay type geometry. So here I'm going to just change this back to my overlay and widening. And here we could see that if we went with that, well, we'd end up with a surplus of, say, 1,600 cubes. Maybe 1,700. And we will go over here. And here, well, we want to have something that ties in nicely with that other geometry. But I'm going to make a new template that doesn't include that extra material class in it. So I'm going to copy this, paste as new. I'm not going to be very original here. I'm just going to call this cross-section new construction. And we could use an entirely different class of roadway component. Or here I can just get rid of this and we can say, well, there's no external reference. We're setting the width of that existing road to be 0. And then I don't have to worry about setting parameters across 2 different cross sections. So we'll hit OK. We're going to apply that new cross section template. And we're going to do our vertical optimization here that, well, oh, and actually I was wrong. Let's go with 1950. So back into the vertical optimizer, taking into account that new cross-section geometry that we have applied. Here, I might have cuts and fills that are greater than 2 meters. So I'm going to bump this back up to kind of a typical value for my band. I'd like to have a nice reasonable spec here. So I'm going to go with min and max grades of 10%. And I'd like to keep my sags greater than 12 and my crests greater than 11. We can add in control points. So the start stays where the start is. The end of this one, well, I want to tie in with that existing grade or that we have in our other alignment. We'll click process. Now here I'm also going to try and remove some insignificant curves. So I'm going to bump that VIP reduction tolerance back up. And it's thinking. We'll let it go. It's not instantaneous. It's solving a pretty big problem. But for the problem that it's solving, it is very quick. And then we'll join our alignments. And we can add in whatever extra details we'd like culverts, and then go over and produce our documentation, export that out, and we'll be wrapped up pretty quick.
This is a good chance to remind everyone, if you've got questions, looks like we might have some time at the end of this webinar, which is unusual for us. So please, open up that question panel, type it in. We're happy to tackle them here at the end.
And we've got a solution. So there we are. This kind of new section or major realignment section makes sense. We are bumping that geometry up here, cutting that down a little bit of that excavation, but taking that material that we're excavating and moving it ahead for those large fills as we go through those two draws. Our solution is balanced. If we wanted to have gotten fancy with it, we could have even added in a pit to account for that extra material. I forgot to do that. I meant to, but we could say at the end of our alignment, we wanted to add that in here, and we could say that, well, we have that 1,900 cubic meters of excavation that comes from our surplus of the other one, and then that would have been incorporated in here, and we could have dealt with that extra material that we're generating there as well. I won't rerun it right now, just as it does take a minute there to run, but yeah. And then of course, if we want to take both these solutions that are, well, have been chunked out to be two separate alignments and join them back together, we can. So we can come up here and click operations, choose what alignments we're joining. We can delete the originals, or we can keep the originals. And there we are. So we've got our solution. One continuous alignment with our proper curve set where we wanted to have that vertical match with the existing ground. We used that temporary cross section and applied it when we did a vertical optimization. And then we've switched it back to actually have the geometry that we'd like to build as we refine this. If we want to get a breakdown of our volumes, we can certainly configure this. So here I've got my subgrade, cuts and fills, surface 1. If I want to add in additional layers, we can certainly do that. So I'm interested in layer 2, 3, and 4 as well. So I can see how much of that we're dealing with. And of course, here there's not much of that extra layer that we have spec'd for that overlay. And well, we could go in and we could add in additional geometry. let's say we want to, let's go, let's dump in a pipe, say there. So if I want to add a culvert to my project, we'll add in a culvert. And we could do that everywhere else that we require a culvert as well. And we could go over to our multi-plot editor. We could put together our documentation very quickly. And here we could build it out from scratch, or we can just grab a workbook that we have set up. So I've got my plan over profile and my section views. And then if we wanted to export the model out, we can hit File, Save As, and we can save that out in a wide variety of standard formats. I'd probably gravitate towards land XML here. So with that, that's my spiel. I think we've got a little bit of time for some questions.
Awesome. Thanks, Matt. Okay, there are a few questions here in the chat. Let's do this first one, which is, how can I control tie-ins at side roads during an overlay?
Yeah. Let's see here. I guess I don't really. I've got a pretty boring project for that one. You could do your separate alignments as a separate alignment, kind of like here, where I've got a few different iterations of the same thing. We could add in those side roads as feeder roads to them, design them in. Of course, in 12, we're launching a new intersection tool, which is very cool to make that even easier, where you can include those, a few clicks of a button, and you've got your full intersection geometry set up for those. I'll hold off on demonstrating that here now. But yeah, it's just a matter of adding those in as you see fit. Now, if it's more of a realignment project where you don't want to just have your road on the existing ground, and if you wanted to use that vertical optimizer, you can add in those control points, and there you could add in at station X, I want to have my road set at a certain elevation. So it preserves the geometry of that existing road or laneway or whatever you want to feed access onto it. Hopefully that answers the question.
Okay, lots of questions. Let's go to the next one. In some projects of rehabilitation, we need to create the best fit center line between two existing road edges. Is there a best way to do this?
Yeah, so for that one, I assume it's the horizontal that you're looking to preserve. So for that, I would gravitate towards using that Polyline to alignment tool that I used. So here I just brought in that surveyed center line. It's not quite the same as what you've described, where you're bounding it based off of your road edges. But you could get around that by giving the software a tolerance that represents the max offset distance that you'd like to allow. So yeah, you can use that, and all it's going to do is basically look to fit as few curves as possible within the tolerance that you've given it, based off of whatever you've fed it for a center line. Yeah, so hopefully that answers your question.
Okay. Next question for you, Matt. And this is one that I'm not sure of the answer of either, so hopefully you've got it with all your wealth of knowledge. Can I visualize where the overlay exceeds a certain depth?
I suppose so. Now here, it's not very interesting. It fits quite well, and I guess, or it doesn't fit well at all, in which case I've used a different template. Now, if we had something like this, where I have it, I used the vertical optimizer to give me that line of best fit, and maybe we'll change some stuff up here. We'll just manually make some adjustments. So here I can see, well, now I've got a little bit of an offset, say 20 cents of an offset. If I wanted to visualize that, well, one, we can see it in the cross-section view. We could add fields in the cross-section. We could add a custom label in the profile. But for a quick at a glance, we could set up shading. So in our plan view, I'll go in here and we could say, well, I want to shade based off of an attribute. And let's change this attribute to be my cut depth. And where is our cut depth? L line. We've got cut depth there. I'm going to remove grade. And we could say, well, I want to see anywhere where that cut depth is between 2 and minus 0.2. And so framing it, okay, we're dealing with cut, so a negative number would be a fill. We'll make that red. We'll make it a little wider, easier to see for folks. Let's go 5. And there we are. So we've got that highlighted as a red area where we're over that spec that we've applied. And we could do a gradient on that if we wanted to have a gradient. So here we've got a couple spots. Well, in the portion that we fit, there's only that spot that I moved manually. But then if we go back to where we've actually allowed it to do some significant realignments, well, we can see where those significant realignments are at a glance. So hopefully that answers your question.
Okay, the next question, which I'm going to answer. So the next question is, do you have readily available guidelines or operating manuals online for these tutorials? And if so, where can they be accessed? So first off, we actually don't have a direct tutorial on overlays and widenings, but that's certainly something we can look at in the future. Right now, we do have tutorials available mostly on sort of the core road design functions. Actually, this week we came up with a new wind farm design course, but certainly we'll make a note here to look at adding a course that talks a little bit more about overlays and widenings. If you're interested in the core road design course, you can check it out. I will put a note in, well, we'll get a note put into the follow-up email here, and I'll do one in the chat as well for our training course portal, and you can check out all the ones there. And if you're interested in practicing with this example that Matt's done today, we're also happy to package up those files and let you play around with them. So that's, yeah, a little bit of an answer to the question about training materials. Matt, are you good for one more question?
I think so. I should be able to swing one more.
Okay. The next one is, can you evaluate changes to drainage patterns caused by the widening? Do I need to take it back to the terrain module? If so, how?
All right. No. So, and here I'm just going to turn some stuff off. All right. Actually, we'll get rid of that one. Keep it nice and simple. All right, so with this, we have our topo. And I'll back up a little bit here and I'll add a little bit of context. At least attempt to add a little bit of context. I'm going to open up that topo file that we're dealing with here. So the short answer, oh, I meant to open it in 12. The short answer is we can use our hydrology tools right in location from 12. But if anyone's new to the tools, I'll give a little bit of a brief kind of overview here to set the stage a bit. So I'm going to introduce the concept in terrain, and then we'll move back into location. So this road that we have is going across the landscape, and well, it looks like there's at least a few obvious streams. So if I were to be in a situation where I didn't have those streams mapped yet, we could go over to terrain modeling and we can click hydrology tools and we can say, well, let's calculate our stream location. And the software is going to look at a minimum contributing flow area, and we can see that those locations where we're likely to have channelization are automatically identified. And for this tool, it's one of those things that it's looking at the minimum area draining to a point. So if we ran that and we said, well, in my particular ecoregion, I have my streams generally start lower in the watershed. Well, we could bump this number up. And well, that's setting the threshold for how large of an area it takes to contribute before we see channelization. So I bump that up here, we run it and see the streams go further down. If we decrease that number, the streams would go further up the watershed. Now with this as well, it's one of those things that, well, it's a surface analysis and what it's doing. So we're considering the surface as a raster, and the software is looking to go to from one cell to the next following the steepest path. And again, kind of setting the stage for what we do in location is, well, here we've got that existing road. It's just looking at the surface. Our water is actually going to probably flow through this thing. So if we added in a hydro enforcement feature, we could do that. Actually, I'll do it over here. I'll do another one. So I've got that added in, and I'm drawing that in. So that hydro enforcement feature is going to tell the software that instead of, well, filling up that sump and flowing down over my road, there's actually a hole through that prism where we can convey water through. So we'll click this guy again, we'll run it, and now we can see that the flow actually goes through those hydro enforcement features that we have assigned. And then again, just before I switch over to location, if we were interested in how much areas or how much flow are we seeing at a specific point? Well, we won't give you the actual Q, but we can calculate the drainage area to a point and calculate the most hydraulically remote flow path. So here, and I'll just tile this, we can see, okay, that's my drainage area to that point, and there's my most hydraulically remote flow path, and we can see that existing road, it's catching water in the ditch and diverting it through there. So that's kind of setting the stage of how the hydrology tools work in terrain. In location, we can say, well, let's look at that pipe that we've added. Oops. So I've added in a pipe here, and I'm going to make it visible in our cross section. So with that, if I were to, if I had all my pipes assigned, I could go in here, and one, we're going to make sure that we have it included in our hydrology calcs. We could say I want to calculate drainage area to anywhere that I have a culvert. If I do this, I'm going to want my existing road to be merged into the topo surface. And here, I'm going to also calculate where my streams would be. And just keep in mind, in this example, I've only added one pipe, so we should see a lot of the water gets diverted by this road that we have. And for the sake of continuity, let's bump that up here, and we'll hit OK. We'll hit OK. And we'll see the software is going to calculate my drainage area to a specific point. But the nice thing that it's going to do here is it's also going to consider how much water that my road is going to act as a dam and redirect flow along it. So there we are. We can see see our flow to that specific point. We could populate the summary in our data table for what's the drainage area to each culvert. And then if it's kind of like what we have here, kind of an intermediate step where we haven't added our culverts yet, well, we've added that one. We can see that, well, we've got some water backwatering back here. Maybe we add in another pipe, or maybe we add in an independent ditch to deal with that ponding area. Here we're doing all sorts of creating all sorts of ponding issues. So we probably need to add in a couple pipes. We'll go one there, try our best to preserve the natural flow patterns. And let's make this guy a little longer. And we'll drop you down. And we could add in another one. So we can quickly add in our pipes, and then we can rerun the hydrology tools and update those numbers as we go. Identify problems, quickly solve them. Pretty easy to work with. So yeah, talked more than I should have there, but didn't want to assume too much to start. But yes, hydrology tools are in location in 12, and they make it really easy to understand how you're interacting with that pre-existing flow regime and the impact your road will have on flow.
Awesome. Well, thank you, Matt. I know we went a little bit over time. It wouldn't be a SoftTree webinar if we didn't. With that, just wanted to let everyone know this is our last English webinar of 2025. Still one more Spanish webinar happening next week if you speak Spanish. So thank you, everyone. Wishing you happy holidays. Yeah, from Matt and I, pretty much your SoftTree webinars team. On the English side, and then Diego and Shadia on the Spanish side. And to everyone, calendar for 2026 is up. We are starting the year off with what we're going to call the RoadEng Industry Series. So we're going to be looking at how RoadEng applies to projects in 4 different industries. Be sure to check it out, softtree.com/webinars. I'll be taking a look at mining, forestry, wind, and county engineering. So take a look. Those will be fun. And like this one, likely going to be showing you guys 12 with its expected release date sometime now in Q1 2026. So thank you, everybody. Thank you, Matt, and have an awesome rest of your day.
Thanks, everyone.